Hello everyone, Accelerators here, and in this video I would like to tell you how the history of video cards began. A video card is one of the most important components of a computer. After all, without video card there was no such cool games with impressive graphics, but where did it all begin? But so the video doesn't last couple of hours. We take a few cards that have been iconic and innovative in different decades and try to tell how certain decades began and how it ended. It's also possible I'll do the second part, if it will be interesting for you. So for the next part, I ask you to distribute this video and better to write a comment. Which video card did you have first? Enjoy watching! We will begin with the emergence of graphics accelerators in the 18th. But it is worth saying that in the 17th computers were not even considered a luxury, they were currently accessible to the mass consumer. Around the same time, IBM made a decision to create a mass computer. In 1981, the first IBM PC was released. Despite the fact the previously well-known corporation preferred the use components of its own production, this desktop consisted mainly of parts from third-party manufacturers. The processor was an Intel 8088 Crystal with a clock frequency of 4.77 MHz. The amount of RAM was 16 to 256 KB. The basic version of the computer was delivered without floppy drives, a hard disk and a monitor. They needed to be purchased separately. In addition to this, various exception cards were separately purchased, among which were video adapters. The buyers offered a choice of two video adapters: MDA monochrome display adapter and CJ color graphics adapter. The first video adapter, MDA, was a bit more popular. Its feature was the work with the monochrome, that is single color monitors. It supported exclusively text mode, 80 columns on 25 rows, and had no graphics modes. The core of the video adapter was the Motorola MC6845 chip, and the memory capacity was 4 KB. The maximum working resolution was 720 by 350 pixels. The CJ video adapter was considered the opposite of MDA. In addition to working in text mode, it could function in graphical mode. Both black and white and color images were supported. It was essentially the first card with support for 16 colors. The core was the same Motorola MC6845 chip, but the memory was 4 times larger. In the operating mode with the color picture, the maximum resolution was 320 by 200 pixels, and with the monochrome 640 by 200. Well, the question is, if CJ was also a text and has mode potential, then what is the point of buying a MDA video adapter? The thing is, MDA was originally focused on the business of the consumer and was imprisoned for working with text. Therefore, he worked with the non-standard vertical and horizontal frequencies, providing a clearer image of characters. CJ supported only standard frequencies and noticeably played MDA as the text displayed on the screen. The logical extension of MDA and CJ was also an IBM extension called EJ, Enhanced Graphics Adapter, introduced in September 1984 for the new IBM PC-AT personal computer. At its core, the new video adapter was the first of its kind able to reproduce normal color images, just like CJ and EJ supported text and graphics mode with a maximum resolution of 640 by 350 pixels, using 60 colors out of 64 possible. At the architectural level, the EJ is similar to its predecessors. He also used the Motorola MC6845 controller. It was equipped with increased memory capacity of 64 KB. The ISA bus was used for data transfer. Over time, the memory size was increased to an impressive 256 KB. Architecturally, the EJ adapter was not fully compatible with NDA and CJ. However, limited supported operation of these standards. For example, an MDA monitor could be connected to an EJ, but in this case only one operation mode was supported with a resolution of 640 by 350 pixels with monochrome graphics. However, in 1987, IBM introduced a revolutionary product based on the VGA standard. The adapter was used by the listed computers at the time. IBM PC2. In terms of architecture, VGA is similar to its predecessor EJ with regard to their functionality. The graphics controller was responsible for the exchange data between the central processor and video memory. By the way, the amount of video memory in VGA adapters was already 256KB, 64KB for each color layer, and the VGA video adapter did not use a digital, but analog interface. The choice in favor of DSAF fell due to the increased number of displayed colors, so the digital interface transmitted RGB control signal in 3 possible colors, and with the use of the analog version it became possible to assign a certain brightness level to each signal. As a result, the number of displayed colors has increased to 262,144 units. At the time, it was a big step forward in terms of increasing the realism of the image. Interestingly, in VGA it became the first video adapter to work with resolution of 4:3, and before the pixels were stretched vertically. The standard developed very quickly. Many different clones of video adapters from third-party manufacturers appeared on the market. With regard to VGA, IBM followed the same policy as with the AMD and CGA adapters, guaranteeing other companies a license to produce customized solutions. Time passed and the quality of two-dimensional graphics was no longer surprising. To some extent, she has exhausted that herself. Naturally, engineers began to focus on processing three-dimensional images. Initially, 3D accelerators were separate boards inserted into 3 slots on the motherboard. However, over time, the 3D accelerator chips migrated to the graphics chip, and one board was responsible for the acceleration of both two-dimensional and three-dimensional graphics. The 19th can be safely called the era of 3D graphics cards. It was during this period of time the formation and development of those companies to this day, so the path of the entire industry for the development of three-dimensional graphics and its hardware acceleration substantially blocked the entire video market. IBM was no longer a leading manufacturer, so the advice of third-party developers came to the fore, and many of them, by the way, were involved in copying IBM adapters. It is believed that one of the pioneers among 3D accelerators for the mass market was the S3 graphics card called Virge, Virtual Reality Graphics Engine, released in 1995. In the same year, the Sony PlayStation console was introduced, so the PC market could already be said to be waiting for a device that would accelerate 3D graphics in real time. S3 released Virge precisely for this task. Compared to today's video cards, the characteristics of the S3 Virge can only cause a smile. The frequency of the GPU was only 66 MHz, the memory bus was 64 bits. A year later, the Canadian company ATI introduced its own development, 3D in Rage. It was slightly modified, namely it occurred 3D support and acceleration functions of the video format MPEG-1. And the 86, the legendary Voodoo Graphics or Voodoo 1 3DFX video card was released. At the graphics processor and memory, Voodoo Graphics work at the frequency of 50 MHz. The memory capacity was 4 MB, and the memory interface was 64-bit. Interestingly, Voodoo had a separate texture model, and this architecture allowed the video card to work quickly and display a very high quality picture. The only drawback of Voodoo was the video card worked exclusively with three-dimensional content, and for processing 2D graphics, the system required another accelerator. Therefore, in the mid-19th, a bunch of Voodoo and Virge graphics cards was especially common, which had tremendous performance in games and other applications related to 3D graphics, and the second in programs with two-dimensional images. The collaboration of 3DFX with game developers has led Voodoo graphics cards to dominate the gaming market for personal computers, so under work with Voodoo games of Tomb Raider series were sharpened. Today, it is hard to imagine the video card market without NVIDIA, but the mid-19th NVIDIA was just starting to gain momentum, and her ascent began with the Riva 128 video card released in the 97. Riva 128 was sharpened for working with DirectX 3D and the OpenGL standard. The Riva 128 graphics processor itself was manufactured according to attention to 350nm technological standards. and it has contained 3.5 million transistors, and its frequency was an impressive 100 MHz. The video card used SGRM memory, the volume of which was 4 MB, and the frequency was 100 MHz. Unlike the Voodoo Graphics video card, the Revo 128 worked not only through the PCI interface, but also through the lasted at the time port AGP1X. The main qualitative difference of Revo 128 was the video card combined with the functions of both 2D and 3D accelerators. And the 3D accelerator used the progressive shared memory. This provided support for high resolutions of 800 by 600 and 960 by 720 pixels in 3D mode. For compression, the Voodoo graphics card in 3D worked with maximum resolution of 640 by 480 pixels. In terms of performance and image quality, the Revo 128 was slightly inferior to Voodoo, but the price of the NVIDIA device was lower. By the way, due to the low cost and simultaneous support of 2D and 3D, many OEMs have made the choice in favor of NVIDIA solutions. Revo 128 was at that time the only direct competitor to Voodoo. The rivalry between NVIDIA and 3dFX in the segment of productive graphics cards has just begun. Further, these companies raised the bar even higher, releasing more powerful graphics cards. 3dFX surprised the market with cards like Voodoo 2, where SLI was first introduced. This was followed by Voodoo 3 in several variants. But NVIDIA did not give a lead, releasing Revo TNT and TNT2, thereby capturing the video card market. Their competitors ATI could not boast of the same performance, but they got their part of the market as budget options. The beginning of the third millennium turned out to be fateful for a number of manufacturers. In the 2000s, the situation of the video card market began to change dramatically. In the last quarter of '99, NVIDIA released its new line of GeForce 256 graphics cards, codenamed NV10. Initially, NV10 was planned to produce 180nm process technology. However, these technological standards were not mastered at the time of the launch of new NVIDIA graphics cards, so the chip was manufactured according to the 220nm processor technology. This contains the core clock frequency of 120 MHz. The green plans had higher frequencies, however, due to possible overheating, the GPU speed was limited to this mark, and V10 contained 23 million transistors. SGRAM or DDR chips were used as a memory. In the first case, the memory frequency was 166 MHz, and in the other it was already 300. The memory bus was 128-bit. Almost all GeForce 256 video cards use the AGP4X interface. Perhaps for the first time it was mandatory for the video card to use a fan to cool the chip, so it was heating in compression with its predecessors. In terms of performance, the GeForce 256 made a big leap forward when working in system with low-cost central processor. In such cases, its superiority to future generations of video cards represented by Voodoo 3 and TNT2 reached 50%. However, with the more powerful CPUs, the advantage was not so noticeably. It is worth noting the GeForce 256 in very rare case fully revealed the potential of the TNL engine, which is why in many games cards supporting the API Glide and Mini-GL looking more preferable. In the meantime, 3dFX was preparing its answer to the new NVIDIA solution, and its 100 chip VSA 100, which was a direct follower of Voodoo 3, the acronym VSA standards for Voodoo's capable architecture. 3dFX slightly changed the idea of building video cards. From now on, they decide to create multiplier solutions for different market segments. In theory, the graphics cards could accommodate up to 32 VSA chips, and performance should increase in direct proportion. Recall, 3dFX already had SLI technology in its arsenal, so the company had some developments for implanting multiprocessor devices. The first graphics card to use the VSA 100 chip was the Voodoo 5. It was based on two stones. The crystals themselves were made using a 250nm processor technology. This is despite the fact the already more subtle 220nm technological standards have been mastered. The chip contained 40 million transistors, the frequency of the GPU and memory was 166 MHz, and the memory capacity was 64 MB of type SDRAM. The bus was 128-bit. For the first time, Voodoo video cards supported 32-bit color in 3-dimensional mode, and the chip was also started with support for textures with a high resolution of 2048 by 2048 pixels. And the algorithms FXT1 and DXTC were used at the tail compression. Another significant advantage of Voodoo 5 graphics cards is their higher performance when using anti-aliasing. In terms of performance, the Voodoo 5500 was ahead of competing solutions in the face of the GeForce 256 and the ATI Rage 28 Max. But she could not become successful, or 3DFX was too late with the launch of a new line of video cards. Nevertheless, the company tried to correct the situation. Firstly, the budget video card Voodoo 4 4500 based on the same VSA 100 chip was released. She used only one stone in her design. However, Voodoo 4 was slow and lost the competing solution GeForce 2 MX and Radeon SDR. 3DFX financial step back surely brought the close of bankruptcy. The launch of productive Voodoo 5 6000 graphics card, which however never saw the light, was become the sound song. The test sample used 4 VSA 100 chips and 128MB of memory. As a result, 3DFX was bought by NVIDIA for $110 million. It was immediately announced there will be no further development of the Voodoo line of graphics cards. Greens were interested in the company exclusive intellectual property, so among other things, NVIDIA has received all the achievements of SLI technology, which is developing and promoting to this day. ATI's answer was the Radeon R100 processor. Based on the R100, two video cards were released, Radeon DDR and Radeon SDR. The first accelerator was considered the oldest on the line. The frequencies of its core and memory were 183 MHz. 128-bit memory bus was used. The amount of RAM was 32 or 64 MB. The interface was AGP4X. Radeon competed GeForce 2 GTS. Let be inferior to the NVIDIA product in 60-bit applications, but in programs that use 32-bit color, it often burst ahead. The younger version of SDR differed only in the type of memory used and lower frequencies. This graphics card successfully competed with the GeForce 2 MX device. 2001 was marked by the release of the next chip from NVIDIA, the NV20, on which the GeForce 3 line of graphics card was based. The processor was manufactured at 150nm processor technology, and the line of video cards consisted of GeForce 3, GeForce 3 Ti 200 and 500 solutions. They differed only in clock frequencies. The rival of the NV20 was the R200 chip. The high-end segment based on the R200 was the Radeon 8500 graphics card. Initially, it was 64 MB DDR or SDRAM, but a bit later 128 MB solutions appeared. The graphics accelerator had a 128-bit memory bus. The core and memory frequencies were 275 MHz. Radeon 8500 is slightly inferior in performance to the competing device in the face of GeForce 3 Ti 500. The reason for the loss was the curved drivers. Over time, where the problem was resolved, the Radeon 8500 sometimes even outperformed the GeForce 3 Ti 500. At the same time, the Radeon graphics card was slightly cheaper. When the companies released both successful and not very good samples of video cards, but ATI won the market more. But 2004, the Greek company returned to the top with the release of the GeForce 6800 video card, codenamed NV40. The GeForce 6800 video cards worked both through the AGP interface and through the PCI Express bus, which was the new at the time. The core frequency of the video card was 325 MHz, and the memory 700 MHz. The memory capacity was 256 MB or 520 MB. The performance of the video card was the highest level. GeForce 6800 pulled the listed games of that time at the highest possible settings. In addition, the results of its power to run games with higher graphics settings were enough for a long time. The response of the Canadian company was the video card of the new line of Radeon X 800 XT. This video card worked at very high frequencies of 520 MHz for the core and 560 MHz for memory. The best was 256-bit, like the GeForce 6800. The best was 256-bit, like the GeForce 6800. Radeon X 800 XT was sold in two versions of AGP and PCI Express. In terms of performance, the ATI video card was not inferior to the GeForce 6800. They were both on the same level, but even so, in early 2005, ATI released a slightly modified R480 chip and a Radeon X 850 graphics card, which was slightly faster than Radeon X 800 XT. And then came the fatal moment. Since 2005, two companies have conquered the market, ATI and NVIDIA. The video card market has finally turned into a confrontation between NVIDIA and ATI and later AMD. The new products essentially copied each other every year. More video memory, the memory frequency increased, CUDA cores were added, but we did not see any truly vivid developments until 2018. There were setbacks like AMD and NVIDIA, but about this somehow in the next video. If you are interested, then do not forget to press the like button and tell your friends who are interested in video cards. Thank you for watching.